Hi. So today I will explain you the part about recurrent neural networks. Last time we have learned about just neural networks. Neural networks, this is something like this. So we have this image and it is 28 to 28, for example, and there is 784 pixels, and you can train neural network which will give in the end this example 0, 1, 2, 3, 4, 5, and it will learn a specified outputs. So by this thing you can train this neural network, so it will predict you what is the number. So what is the problem? Cat dog, okay. uh, So there is some special case, like says here the output of cat doesn't relate to the output of dog. So if you put cat and then dog, it doesn't matter. So, but there are several scenarios where you should have some insights about the previous data. So, for example, about weather, today's weather is dependent on previous days with weather. So, for example, we have mostly known that if yesterday was good day, so mostly it will be good day today also. But sometimes it change, and so for example, the the amount of you sleep today also depend on previous day, because if you sleep not enough yesterday, you will have to sleep more, and many things like if there was something yesterday, so today it may depend on this one. So this is called time series, like when data is all depend on time. Also this can be, for example, for natural language processing, word is dependent on previous words. So you should know something about what was before, and this is important. So for example, if you are wanting to find named entity which is like dependent on previous words, so you can make them as a feature, but also you have to specify how many features you should look. But you want not to specify, but to a computer find it's by itself. So the very first solution which was given, it was about RNN, recurrent neural networks. Uh, so this is something like recurrent neural network. Its definition. So you see here x0, x1, x2, xt. So this is inputs, and this is outputs h0, h1, h2, ht. So this is something like outputs. A is a network. So you take this data and input here, multiply it, and then it will output some h0, and after that it will generate some new vector, and then you take this vector and this vector, multiply them, and you will got this a number. You again get this h1. So in the beginning it will have like initial some data. So different type of elements. Okay, let me show. So let me show some small examples of how to develop recurrent neural networks. Okay, got problems. Okay, so this is different types of RNNs. So this is actually like mostly same as before. It's neural network. You give input, it has some thing, and then you output. And then this one, for example, one input, and then it generates some output here. Then it goes to next point. It again generates on the previous, and the zero input generates this one. You give this one, and then it goes, and same for this one, this and this. So this is all are types of recurrent neural networks. So for example, this one can be like some you input text and it should output it one one word and it should output maybe it's so actually it is okay, one to one. So one to one is actually a simple neural network. But for example, this one to many. So for example, you give one word, and it should write some text about this word. So you give it one word, and it tries to generate many words. Oh, sorry. And then this one, so maybe not mostly in case we will not see it like this one. This one is you give, for example, text, and it in the end outputs its class. Not class, but vector, one vector, and you can use this vector to classify it. So for example, you give here text, hello world, and etc. And here it must show it was written in English. This many to many. So this one, for example, maybe for machine translation. Here you write in text in English, like hello world, and here it will start hello world end of symbol, and here it will start as Salem Alem here and end of symbol. Something like this, and many to many. So same for machine translation can be used for here, but sometimes this is better because it stores all information into one vector, and then you can use this vector to present all this. So for example, this can be word-to-word translation without any things. So for example, it's written here, image captioning takes an image. Oh, okay, so this one so here you input some image and it outputs text about this image. This one, sentiment analysis, you write text and in that it show this one. And for machine translation, as I said before, synced sequence. Okay, so this is video, and here you will have some files. Each rectangle above image represent vector, and arrows represent a function. So this is vector. So okay, this one vanilla neural network. So this is simple neural network. It deals with fixed size of input, fixed size. So we have seen it before. It is very clear. One to many. So this is example. You give one image, one only image. There is no sequence of images, and it shows you what is this one. So there can be many results. Many to one. Sentiment analysis, many to many. It's machine translation, bidirectional. CNN, we'll learn CNN later. So this is input V1, B1 in the end. Okay. This is single neuron. You have weights, bias, and on the output you have output. And this is input, and here it will have weights and bias. So weights and bias will change over the time. So here is an example. So this is like general simplification, but when you unroll it, it will look like something like this: x1, x2, x3, xt. So we have x1. You multiply it by some number, and it will give you some h1. Okay, so we can see. So xt is some input. So for example, is text classification. It can be one hot encoding or word-to-vec, as we watched before. So what is word-to-vec? Is some vector which is by which you want to present your word. So for example, you have word, and by word-to-vec you have 300 size vector of size 300, and you use function sum, and you have ht. So this is hidden, ht minus 1. So if this is first, it will have h0 and no x0, and some by default values h. You can also train them. You concatenate them, you take them together and put it, and then it will be sent here, and there will be some operation with them. Mostly it is, for example, you can use sigmoid on tangents. So it is like processed, and in the end you get some output. Also, as in neural network, simple neural network, you have input, but in previously you have inputs, only inputs, and then it go. But now you have inputs and previous, some data from previous, some previous information. You then multiply, then you got these two things, VOH, V output H, B0, V hidden H. So again, it will also generate two parts. So actually it is generating one part, but you can divide it in two parts. So for example, first half will go to this output, and second half will go to next output. Applying activation function. So there is a function which is called tangents hyperbolic. It is between 0 and minus 1 and minus 0. It is very simple function. We have do not have, but it's the simple function. It's also used instead of sigmoid because it has some function. It has some something that overcomes of sigmoid. There is no zeros, and so we can use it. HT, we multiply weight with hidden from previous. So we take, there is some hidden. We multiply it, and then we plus xh and t. So it is weights. So there are weights for previous data, and there are some weights for this data. You multiply it, and then you got ht, the new ht, so you generate h1. Output, so output will be you multiply weights, so there is also weights, and multiply by ht, you got yt is output state, and then you use this one, weights, not weights but ht, in next iteration. So this is something like this. There is some hidden vector. You take xt, x1 and multiply by wxh. So there are some weights, but in the beginning they are random, and then you plus it to hidden at t minus 1. So we take the default h, which is randomly, and then you take this also randomly, and then you plus it to weights and x is input. So these things in the beginning, these all things are randomly put, and this is set, and then you got ht, and then you got output, and in next time you, for x1, for x2, in the beginning we said that all of these things were random, but for x2 you have x2 here, and these things also will be that set randomly, but this one will be from previous example. This number is got from previous example, from x1, and you multiply it, and then you use it. You should output. So this is called recurrent neural network. It's called recurrent because it uses previous value. So it is based on some previous value, and by doing this you have some information about previous things. Character level language model. So this is, for example, how to use it with some neural network. So for example, this is called character-based neural network, and here you have hello. So here h is 1000, 0100. So this is some input layer. Why it is called one hot vector? So it means that this is placed for h, this is placed for e, this is placed for l, this is placed for l. So this neural network's goal is to predict what is next. So for example, you write hell, and it must write here O. So hidden layer, you multiply it and got these numbers. Then you go to, send these numbers to, and perform some operation with this one and multiply it, and this one and multiply it, etc. And now we have to do some training. So this is works if you have some data, but now we have back propagation over time. So you have x0, x1, x2, x3, x4, and e0. So for example, you get some result, multiply it. So it'll just in like neural network. You multiply, but you have to change all of these weights. So for example, you give this error and you will get through all of these things to change it. So it says going back into every timestamp and updating its weights is a really slow process. It takes both the computational power and time. So in neural network you have something like this. You take one value from the top and you go back, and each of them can be computed separately. So you have this number, you go back, and for each you can go back. So because of this we use video cards, because video cards calculate parallelly, but this one is like also neural network, but it cannot be parallelized, because to find this weight, to change these weights, you go from this one and change every weight. So you cannot change this one until you change this one. So actually there is it goes it should pass all of this input. So if you have very long 6 sentences, it will take a long time. So it has also problem vanishing gradients. Vanishing gradients, where this contribution from the early steps becomes insignificant in the gradient descent step. And so, sorry, I will be very near because of the noise. And here, vanishing gradient. So it means that the numbers will be very like so. If you go back from these points, every time you multiply this weights are actually small numbers, and you multiply it by some value, and it changes for small numbers. And for small numbers, you use, for example, 0.1, change this weight, but this weight will change 0.01, this weight 0.0001, and 0.00, and many. So if it is very long, this 0.01s, it is every time multiplied by some 0.01 values. In the end, this one will become the number which cannot be stored in computer because it's very small, and it will not change it to the end. Also, if there is some error, you can wait till indefinitely to change it, because it changes for some value, and when it comes to here, it is very small. So if you have very errorful initializations here, so they will not change. And exploding gradient, so you see here example, you change it one, so until it changes here, there is very little changes. And exploding gradients can be overcome, so it will be very big weights. The main advantage of RNN over INN is that RNN can model sequence of data. So if you have sequence, if you have data which is in sequence, and this data is dependent on previous data, so there should be some understanding of how data occur, because in neural network you cannot, there is no sequences, there is only some values. So you can measure sequence, but it should be like by using RNN we actually give a hint to neural network that there is data which are they are very near to. So for example, in this case, so in this example, you see that there are, so for example, there are points which are near, they are actually important to each other, how they put it, but this neural network doesn't know about it. It only knows that, for example, if the pixel is here, it might be 2. The importance, if it is 2, it becomes more important, but for example, if we could make it smaller, then it would be better. And so recurrent neural networks are good for natural language processing. Advantage, recurrent are even used with convolutional layers to extend the effective pixel neighborhood. Okay, so we can pass it. Gradient vanishing and exploding problems. So this is disadvantages. Training NRN is very difficult task. So you cannot. You can use neural network video cards, but video cards will not help to solve it. It cannot process very long sequences if using H or ReLU using this. So also for long sequences, it cannot store the all problems. To overcome this problem, there is some such architecture which is called long short-term memory. I will not explain it in details. If you want, you can learn better. But it's something you create inside of your recurrent neural network. You create some new neural network, which not only neural network but also neural networks which learn how to forget and how to remember. So for example, we have this problem that it goes from the beginning and till the end, and it only stores one value, one vector, which says what to it only stores one vector and changes vector over time. So it means that if some words, if some data was important that in the beginning, and now you should know about it. So for example, the example is so there is an example. Okay, so yes. So for example, let's give example. John lived in France, so he knows. So for example, you have to predict this word. So for example, if you think logically, this must be French. But John is in the beginning of the text. So what does it mean? It means that but our neural networks will remember only these parts, last parts, because these parts will be like they are somehow not important. So okay, so called friends. So this we need the word friends. So and it was very long ago. Again, this is not long ago, but there can be some examples where it was in long ago, and you can our neural networks, for example, only remember these parts. He knows and something like this. But now French is not like important. So to this thing, it helps to remember and to forget. So for example, you see here forget gate, output gate, and input gates. Also, it has contained some cell state. So this is cell state is some vector of size this one, and it says these things should be forgotten when you multiply it in the end, so, okay, you multiply it in the end, it will say, okay, forget, do not watch onto this number. So for example, we say the word he, forget word he, it doesn't matter, but do not forget about that he was John. That well, no, sorry, that some country name was John or France, and after that it should be depend on this one. And forget input, so you get forget output multiplication, and use after that you change cell state. So every time cell is recalculated, and by recalculating you say, okay, these things you should forget, these things you should remember, and then this one is outputting, and you decide what to output on the end. This is also example, so this is called different operations. You have one more value, which is cell state. Before we didn't have this cell state, we have only next input. So you see here forget gate, it says forget about this one, because in the, for example, you are talking about some persons and there was a person before and now you have new person, so you say, okay, forget about this part which is was about person, and the output gate is what to do, what to output here, and then in the end it goes this forget gate and then input gate. So for example, there is new information, here you say what to forget, here you say what to new thing. So for example, you come here, John leave it in, and you see friends, and you say, okay, remember that was some friends, that friends was, and maybe you should remember it, and it's stored somehow. Forget gate, okay, we do not okay. So here in the example, how to make yes, sinus wave. They tried to predict sinus wave, so you have sinus wave and you have to predict next value.